Hey y'all, we have been talking the last couple lessons about distribution of sample proportions and sample means, and we use those to find out if things were likely or unlikely. We could use those to find probabilities of things happening, and so now we're going to use those in other ways. And today we're going to talk about confidence intervals. So suppose we take a random sample of 510 people, like they did in the Gallup poll, and they asked them how they feel about the use or the application of the death penalty. And so 58% of the people in this poll answered that they feel like it's applied fairly, 36% said unfairly, and another 7% said they didn't know. And I'm pretty sure if I remember from experience that this doesn't add up perfectly to 100%. Let me double check. Yep, I'm right. I think it's about 101%. So probably what happened here is they rounded their percentages just for ease of conversation. And so just be careful with that. When we round, it sort of distorts reality a little bit. Um, but for the sake of this question, we'll use these numbers. And so we're looking for some sort of conclusion. And so I want to propose to you, what if we wanted to really find the true proportion? Now, these are American adults. What if we wanted to really find the true proportion of the population proportion of adults who believe that the death penalty is applied fairly? So it would be impossible to find the true population proportion. There's too big of a population in this country. It's impossible to reach everybody. It would be just not worth our time or money. So what we can do is we can create this thing called a confidence interval. And that's an interval of numbers that we can say with some level of confidence, which I'll talk about in a minute, uh, our population proportion would be between. We don't know 100% for sure, but we can say so with a certain level of confidence. We can estimate the true proportion, and we'll show you how. So let's talk first about the confidence interval sort of formula. You can see here I talk about a z interval, and it's one proportion. So we have one proportion, which might lead you to believe at some point we're going to talk about two proportions, and we will. Uh, Calling it a z interval might lead you to believe that we're going to be talking about some sort of other letter interval, and we will. We'll be talking about t intervals, and if you play with your calculator a bit, you'll see those in there. But for now, we're using a z interval, and that z refers to this z here. But let me talk about the pieces here. This p hat is a sample proportion. So we have a sample. We don't have a population proportion right now. We just have a sample proportion p hat. And we call that a point estimate. So if we were to find all the possible samples, I believe of 210 people, all possible combinations, and we plotted those proportions onto a distribution, it would be approximately unimodal and symmetric, approximately normal. And this one sample would be 1 point. So this one proportion would be 1 point on that distribution. So we call it a point estimate. We are estimating the true proportion using one sample. And that's not super accurate, so this is why we're going to create this confidence interval. So you see there we have a plus minus, and then on the right we have this z star times this square root of p hat q hat over n. And this should look familiar. It's the standard deviation of the distribution of sample proportions. What's different here is instead of pq, we have p hat q hat. We have to use p hat and q hat because we don't know the population proportion. We don't have p. That's why we're making this interval. And so what we end up calling this piece instead of the standard deviation is the standard error. This z star is what we call a critical value, and we can calculate that using our calculator, and I'll show you how to do that. And then so once we put this z star times the standard error, we call this whole right side a margin of error. You know, people a lot of times in life use that like give or take. You know, uh, Yeah, he's about 35 years old, give or take 2 years. They're giving themselves a margin of error if they're trying to guess somebody's age. And that's kind of what we're doing here. We have this sample proportion. We're going to use this right side here to give us an interval. We're going to get two values. And we're doing a margin of error. Our sample proportion is approximately the population proportion, give or take this margin of error. Um, and this critical value is where we get our confidence. This is based on a confidence level. And we usually use like 99% confident, 95%, 90%, 80%. Those are different levels of confidence we're going to use, and we can see how we can put that in the calculator to calculate a z star. If we were 100% confident of capturing the proportion, that would mean that the proportion would be between 0 and 1. Uh, we can be confident that any proportion is between 0 and 1, um, and that's not really informative, so we'll be less than that for sure. So we have to meet assumptions and conditions. They're the same as the assumptions and conditions that exist for using the distribution of sample proportions. We need to be random, we need to be independent, and we need NP and NQ to be greater than or equal to 10. I'm not going to spend a lot of time on that right this second because we talked about it last time. If you still have questions about this, though, you should definitely ask me for help, and I'll be happy to discuss them with you. So let's get back to our Gallup poll. And I want to document some things here real quick. So I like to start by documenting the values I have. So my sample size is 510. P hat, that's my proportion of interest here. Success is somebody saying they think it's fairly applied. So Q hat is 1 minus P hat, 0.42. And unfortunately, I can't get my calculator to work here because my computer thinks it's connected to my smartboard at home. Um, so I'll show you how to use the calculator in class to calculate Z star, but this is going to be 1.96. It's a Z because it's like finding a Z score on a normal distribution. So it's related to that. If you're thinking it might be, that's because it is. So what we could do is inverse norm after we do second vars, and we could tell it an area of 95% in the uh, in the center. You have that option. You can choose center, and basically what we're finding is what is the Z value right here, and there would be an associated symmetric minus Z, so it's negative 0.196 over here. That cuts off 95% of the area underneath the normal curve. I can show you how to calculate that since I can't pull up my calculator here, but you use the inverse normal, tell it you want the area of 95%, so 0.95 in the middle, in the center, and it will tell you a Z value. And that's that Z star. So 1.96 and negative 1.96 cut off approximately 95% of our distribution. So I'm going to quickly document our assumptions and conditions, and then we'll have a chat about them. So we do have a randomly sampled 510 adults. 510 adults is certainly less than 10% of all American adults, and so we can say that each adult's opinion is independent of the next adult's. NP and NQ are both greater than or equal to 10, a lot greater than. That means we can expect around 296 people who say it's fairly used and around 214 people who say it's not fairly used. And I should put little hats on here because we're using P hat and Q hat. Okay, I'm gonna go back up here actually and correct that. We don't have P or Q again because all we have is a sample. But we want to make sure that our sample successes are greater than or equal to 10 and our sample failures are greater than or equal to 10. And so now we want to create this interval using that uh, interval that I showed you up top. So I'm going to go through that and then I'll explain it. All right, so I plugged my values into that formula that we had above. P hat is 0.58, the Z star is 1.96, P hat 0.58, Q hat 0.42, and my sample size N 510. And I boiled that all down. to 0.0428 on the right. This is my margin of error. We call it ME. And so I'm going to add or subtract that to 0.58, and I get this. We report the interval in parentheses. It kind of looks like coordinates, but it's not. It's in parentheses. And so that means that my interval starts at, if we want to talk percentages, uh, approximately 53.7% and 62.3%, approximately. And so what this means is that we can be 95% confident. And actually, let me write this out real quick. So what this interval is estimating the true population proportion of U.S. adults who believe the death penalty is applied fairly. And so we use a 95% confidence level, and that's 95% helped us find that Z star. And so what we can say is we are 95% confident that the true proportion of U.S. adults who believe the death penalty is applied fairly is between that 53.7% and 62.3%. Right smack dab in the middle of that is our p hat, our sample, 58%. And then to the right or left, we used our margin of error to find those boundaries. That 95% confident isn't a probability, so don't be confused. And this is something that I can clear up in class, but let me try to explain it to you. It means if we were to keep sampling 510 adults, and we got every possible combination of 510 adults, and we found the proportion of them who thought the death penalty was applied fairly, and we made a confidence interval, 95% of those intervals would contain the true uh, proportion. So if we could create every possible interval like we just did for this 510 adults, 95% of those intervals would contain the true population proportion. It's a little murky when you hear it, so I can explain it multiple times, and just keeping saying it is what kind of clears that up. This sort of interpretation can be sort of formulaic. You can always start with where we are blank percent confident, and you always want to say what it is you're confident about. Um, Here we are talking about a proportion. We will talk about means. We'll talk about difference of proportions. You always want to put the context. We're talking about American adults, U.S. adults, and that their belief in the death penalty is fairly applied. And then, of course, you always want to put in your interval. So lots of things to hit here in like one sentence, but you can sort of do it formulaically. Just say it the same way every time. It doesn't have to be creative or eloquent. It just has to say uh, what the interpretation is. So that's a lot in a quick lesson. Please ask me for help if you need help. If I can re-explain the interpretation, if I can re-explain what 95% confident means, if I can show you on the calculator how to calculate Z star, I'm absolutely more than happy to do that, and would love to do that. So please ask for help if you need it. Do some practice. Good luck.